Get going here. And the recording's going. It's all yours. I will put myself on mute. And then do you want the questions before or after or during?
I'll probably say at the end of certain sections, are there any questions, if that's okay?
That's fine. I'll just be on mute, so I'll come back then.
Excellent. Thank you very much.
Thanks. Here's Andrew.
Hi there, everyone, and welcome to this session on SQL Server and containers. Let's just sort myself out. About myself here, my name is Andrew Pruski. I'm a SQL Server DBA, originally from Swansea, Wales, but I've been living in Dublin, Ireland for around 3 years now. Been working with relational databases in one form or another for about 10 years. 6 of those as a SQL Server DBA, and I've been working with containers themselves for about 2 years. My Twitter handle and my email address are up there at dbafromthecold and dbafromthecold@gmail.com. So if you have any questions after today, feel free to ping me up. And Tom, I don't think you're on mute there.
Oh, sorry about that. Let me get myself on mute.
No problem. So yeah, those are my contact details, the Twitter handle and the email address. If you have any questions after today, please feel free to ping me. I'm always willing to talk about this stuff. My blog's there as well, dbafromthecold.com. So if you want to go into a little bit more depth, I've got a few posts on containers up there at the moment, some of which I'm using to base this session on, and some that go into a little bit further detail. So if you want to check that out, you're more than welcome. On to the session. The aim of this session is to give you the background knowledge and commands to be able to go away and evaluate this technology for yourselves. There's a lot of buzz about containers at the moment, but not so much in the SQL Server world, which I find odd, because this technology really has some benefits for us as SQL Server people that are worth exploring. It has some drawbacks too, which we'll cover, but I'm hoping after today you can go away, play with this stuff, and make a decision as to whether or not it can benefit you in your day-to-day work. So there are other container companies out there that will do you an instance of SQL in a container. I think Spoon.net will do a SQL Server 2014 Express edition in a container. But as they announced a partnership with Microsoft way back in 2014, and official support came out at the end of last year, the technology company that we'll be focused on today is, of course, Docker. So here's what we'll cover. We'll start off with a bit of container theory, so their definition, what they are, the different types available to us, how they compare to virtual machines, a bit of container networking, and then the pros and cons of the technology. Once we've got that, we'll go into building our first container. So setting up Windows Server 2016 with the Docker engine, and then pulling an image from the Docker hub. Then we'll run our first container, and then we'll look at building custom container images. Once we've got that, we'll then look at pushing and pulling from the Docker hub. And then finally, if we've got some time, I would like to talk about how I've implemented containers at my company, the issues that we were having that we thought containers could resolve, the architecture that we built, the benefits that we saw, and the issues that we run into along the way. But first, what are containers? Now, the definition on the screen there is from the Docker website, and it says that container is an object that contains all the necessary binaries and libraries required for a piece of software to run in the same manner, regardless of its environment. Basically, a container is an isolated place where an application can run without it affecting the rest of the system, or the rest of the system affecting it. In practice, they're lightweight objects specifically tuned to perform, say, one function such as running SQL Server. They are quick and easy to deploy, easy to customize, and easy to share. So very brief here, just some container fundamentals. First one there, the container host. This is obviously the machine that we'll be running our containers on. And for us as SQL Server people, that's going to be running Windows Server 2016, or if working locally, Windows 10, Pro or Enterprise Edition with last year's anniversary update. Then we have the container engine. This is the service that we interact with to deploy, run, and build containers. We can also send it a variety of commands, such as how many containers do I have and what state are they in? Then we have the container registry, which is simply a local repository that we have on a host for storing container images. Now, these are explained to me as the installed state of an application in a reusable format. I like to think of them as baselines that we can use to build containers from. And any container built from an image will be a carbon copy of all other containers built from that image. So when it comes to Windows containers, we actually have two types available to us. We have Windows Server containers and Hyper-V containers, and both offer a different level of application isolation. Windows Server containers perform application isolation through namespace and process isolation technologies. However, they share a kernel with the host and all other containers running on that host. Hyper-V containers take isolation a little bit further by running each container in a highly optimized virtual machine. Therefore, they don't share a kernel with the container host or any other containers running on that host. Now, in practice, I've only ever used Windows Server Containers because they give me exactly what I need. And what I need is the ability to spin up an instance of SQL Server in a very short period of time. I don't really care about the level of isolation that I'm getting, but I appreciate that your needs may vary. And so that's why I've dropped this slide in here to make us aware of the two different types. And it is really easy to build Hyper-V containers instead of Windows Server Containers. You just have to have the Hyper-V service enabled on your server, and then there's an extra switch that runs here. For the purpose of this session, we will stick with Windows Server Containers. Those are the two types available to us, but how do they compare to virtual machines? On the left there, we have the virtual machine infrastructure that we've come to know and love over the years. So at the bottom, we have our infrastructure, our host, and then our operating system and the hypervisor on top of that. Now, I know with certain hypervisors, these like ESXi, excuse me, a bare metal type 1 hypervisor, the operating system and the hypervisor are one and the same thing. But if you look at Windows Server 2016, you have the operating system, then Hyper-V running as a service on top of that. So that's why they're split out there, sort of. But on top of all of that, we then have our virtual machines with their full-blown guest OS, applications, and NSE binaries and libraries required to run those applications. Moving over to the container side of things, things are a little bit different. We have our infrastructure, our host, our operating system, Windows Server 2016, and then the container engine running as a service on top of that. On top of all of that, we then have our containers. And here's the key difference. The containers just have the necessary binaries and libraries required to run whatever applications in them. They don't have a full-blown guest OS like virtual machines. And that means that their footprint is significantly less than virtual machines. You can run a lot more containers on a host than you can virtual machines without oversubscription. But one thing I would like to point out is that I'm not advocating that containers are going to replace virtual machines. The way I like to think of it, and the way it's explained to me, was if you have an environment where you need to do one thing lots of times, containers could be your way forward. However, if within that environment you need to do lots of different things, a virtual machine is still probably your best bet. Okay. I do want to briefly touch on some container networking. So just we need to know how to connect to these things once they're up and running. So we have our container host there, and that's the black box, and it has network connectivity provided to it via a NIC card. And it needs to extend that network connectivity to the containers, and it does this via a Hyper-V virtual switch over which inbound, outbound traffic is forwarded. And all the containers connect to that Hyper-V virtual switch via a virtual NIC that's created on the host. By default, when the container engine spins up and when the containers feature is enabled, a NAT network is created, and the default gateway of that NAT network is assigned to that virtual NIC. Now, that's important because it allows us to specify port mappings so that endpoints within the containers are accessible to external clients, such as SQL Server Management Studio. What we'll see in practice, when we spin a container up, the container engine will assign it a private IP that we can use to connect to if we're connecting locally on the container host. And if we're connecting remotely, we use the container's host name or IP and a port number that we specify upon container creation. Okay, I think that's enough theory. Let's get into the pros and cons of using this technology. Starting off with the pros. Why do I want to use this? So the first point there, simple and fast to set up. For Windows Server 2016, it literally is 2 PowerShell scripts and a bounce, and then you are up and running and ready to build containers. The containers themselves can be spun up in seconds. You can have an instance of SQL Server up and running in literally seconds. I've already said relatively low footprint compared to VMs. My company at the moment, I'm running anywhere between 30 to 40 containers at one point on a host, using about 50 gig of RAM and 200 gig of disk space, arguably far less than if I had 30 to 40 virtual machines running there. The ability to customize images. Now, this is a huge plus point with containers. So we have access to the Docker repository, which is an online repository full of hundreds, if not thousands of images. Okay, as SQL Server people, we're only going to be interested in a few of those images, the SQL Server images, but not only can we pull them down and use those images, but we can change those images so that when we spin a container up, we have an instance of SQL Server that's not only configured how we want it, but has our development databases up and ready to go. It's incredibly powerful when it comes to building development environments. The last point there, portability. Images can be saved to the Docker Hub. So not only can we pull images down, but we can also push images back up to that hub. Really, really handy when it comes to sharing images with, say, remote development teams. Okay, starting to sound like a little bit of a Docker fanboy now. It's probably because I am, but what are the cons of this technology? Well, there's got to be some drawbacks, right? First one there, unfortunately, only the database engine is supported. So no integration services, analysis services, reporting services, not even the agent is there yet. The agent service is there with Windows containers, but I've tried spinning it up and all I do is get a host of errors. If you can get the agent up and running in a container, please let me know. I'd love to get it working. This stuff is only supported on Windows Server 2016 or Windows 10 Enterprise Edition, Anniversary Edition with the Pro or Enterprise. So if you're running a lower version of Windows Server in your production or development environment, that could be a blocker for you. Official SQL Server images for 2016 and 2017 from Microsoft only on the Docker Hub. There was an image for SQL Server 2014, but it was deprecated, and I believe it is now gone. So if you're running and need an earlier version of Windows SQL Server, that could be a blocker for you as well. However, for both of those points, there are other options out there, and I'll discuss those towards the end of the presentation. Next one, SQL Server images aren't the smallest. They are around 13 gig. So it might not be a problem for you if you're working in an office with a lightning fast broadband connection. It's not going to be much of a problem. But if you're me, say working in my lab at home with my, if I'm lucky, 7 megabit connection, it can be a bit of a pain. The last point there, suitability for production. It's more of a discussion point really, and just to get you thinking about how to use these things. Because if you think about the points I've mentioned, quick and easy to set up, easy to spin containers up, are they applicable to a production environment? I don't know about you, but when I'm setting up a 24/7 critical instance of SQL Server, I kind of want to spend some time building that, customizing it, and configuring to exactly how I want it. Maybe in a DR scenario where I need to get something up and quick, really up and quick, it could be handy. But I'm really on the fence at the moment whether or not this stuff is suitable for production. Okay, so I think I've talked about theory enough. Let's actually get into building our containers. So the first thing we need to do is install the Docker engine. And as I said earlier, it is really simple to get this up and running. It is literally 2 PowerShell scripts and you are good to go. Now, I know there's 4 there, but I'm not counting, I'm not counting the bottom one now because it's just a bounce. And this one at the top here, the NuGet package provider, you don't need to run that. I've just left that in there to know there is a requirement. But if you run this script here, install module named Docker MSFT provider, which is a PowerShell module for discovering, installing, and updating the Docker engine, the engine will come back and say, do you want to install the NuGet package provider? So it's not a problem. So you run the install module for the Docker MSFT provider, hit execute, wait for that to install, and then we are good to go installing the Docker engine. So we run install package named Docker provider, the MSFT provider, hit execute, wait for that to complete, give our server a bounce, and then we have installed the Docker engine. Simple as that. Once the server comes back up, we do need to do a couple of checks. First one there, just double check that the containers feature has been enabled for us. If that's all good, we can then start interaction with the Docker engine. And the first thing to do, just double check that the service is up and running. So we just say it's Docker. If all's gone well, we've got a status of running, and then we can send our first Docker command. And I like to keep it really simple. So I just like to say, hey, Docker, what version are you running at? So Docker version. And if everything's gone well, we've got a client and a server version there. So we know our service is up and running and responding to requests as expected. One little bit about Azure. If you are working in an Azure lab, you don't need to run through the setup because Microsoft have quite kindly created an image for SQL Server 2016 with the containers feature already enabled. They've also downloaded a couple of images, but I think they're for Windows Server Core and Nano Server. So you will still need to go off to the Docker Hub and pull down a SQL Server image, but it's one less step that we have to do, and I'm all about making my life a little bit easier. Windows 10. What I usually do now with these presentations is go in and show you the install process on Windows Server 2016. But it really is just running 2 PowerShell scripts. So I thought what I'd do for these live demos is work on my Windows 10 box. And the install is a little bit different. So you need to download an installer from the Docker store, bring that down, and then run through the normal double-click next steps. But let's actually go, and I want to show you a couple of things on my setup here that's kind of cool. So what we have is my Windows 10 installation, and I've installed the Docker engine. And before I install the Docker engine, I have the containers feature and the Hyper-V feature. Ran through the installer, gave my machine a bounce, came up. I can verify that the service is up and running by this kind of cool little icon down here. Where are we? Let's try that again. Thing just telling the engine is up and running. So what I'm going to do for these demos is I'm going to show you the scripts for running all this stuff on Windows Server 2016, but I'm going to work locally on my Windows 10 box. I'm going to work against Linux containers running SQL Server because I want to show you that the commands are pretty much identical. There's 1 or 2 little differences, but if you're like me and you've worked mainly in a Windows environment, this is a really cool way of getting involved with SQL on Linux. And the way Linux containers on Windows 10 work is when the Docker engine spins up on your local machine, it actually starts up a little Linux here, and that's how we get Linux containers on Windows. One thing to mention about this is that when this spins up, you get a memory of 2 gig. There we are. You get a memory of 2 gig, which isn't enough to run SQL Server containers. You need at least 3.5 gig. So I've given this one 4 gig, and we're good to go. One thing, don't change the memory here. Actually do it down through the little Docker icon right on it. Settings, advanced, and you can change it here. If you change it in the Hyper-V manager, the changes won't persist. So do it here, and Docker will start it up for you, and the changes will persist. So that's my Docker engine up and running on my Windows 10 box. So I'm just going to double check to make sure that everything is up and running. So I've got my PowerShell project. I'm going to say Docker, version are you running at? Boom. And this is kind of cool. I like this. We've got an OS of my client of Windows and OS of Linux for my actual server versions. But I've run my first command. Docker is up and running, and I'm good to go building my first container. So let's jump back into the slides and have a look at what the commands we need to get our first container up and running. So we want to build our first container, and the first thing we need to do is identify an image on the Docker Hub that we want to use to build containers from, and we do that via the Docker search. So you say search for an image for me, and it's going to be Microsoft SQL because we're interested in the SQL Server images, and it's going to pump out a big long list. And we're going to be interested in the Windows Server, which is the 2016 in a container. SQL Server Windows, which is SQL Server 2016 edition. Or for working as I'm going to be on my 10 box using Linux containers, I'll go for SQL Server 2017 on Linux. So we've got a couple of options there. What I'm going to go for in my looking on Windows Server 2016 is the Windows image. So I need to pull that down to my local repository. And I do that via the Docker pull command. So say Docker pull Microsoft MSSQL-server-Windows. And that may take some time depending on the internet connection because it's around 13 gig. But once it's complete, we then to verify that it's been successfully pulled down into our repository via the Docker Images command. So we say Docker Images, and this just shows us a big long list, or not so much in this case, there's only one image there, of all the images that we have in our local repository that we can build containers from. So we have it in our local repository, and we can now build our first container. And we do that via the Docker run command. So what we're saying here is we're saying Docker, run me a container, -d, run it in detached mode. So run it in the background so I can continue using my shell. -p, which what I'm doing here is specifying that port mapping. Remember that NAT network? So I'm saying here, map port 15789 on the host to port 1433 within the container. So what this does is any connections hitting port 15789 on the host will be automatically mapped into the default port that SQL listens on within my container. Next, we're going to specify a couple of environment variables. So we're going to accept the end user license agreement. If you don't specify this, your container won't run. And then we're going to set an SA password because we need to be able to connect to our instance of SQL. Then we give our container a name. And then we specify the image that we want to build our container from. So that's the image we've just pulled down. We hit execute. Docker will come back pretty much immediately with a big long ID that identifies our container. And then we're waiting for our container to spin up. When our shell returns, we then need to verify that our container is up and running. And we do that via the Docker PS command. So Docker PS by default shows us all containers that are running on our system. And if everything's gone well, we have a container there with a status of up. If something hasn't gone well, our container won't show up there. So we need to run Docker PS-A, which is for -all, show me all containers on my system, no matter what status they have. And if you're me, it's exited out, and I'm going to have to run something like Docker logs, my first container, show me all the logs of the container, and it'll probably come back with something along the lines of, you need to accept the end user license agreement. So I'll go back to my run command, drop in the environment variable, run it again, wait for it to exit, and then hopefully this time I will end up with a container that's got a status of up. So we have our container up and running, but how are we going to connect to it? So if we're connecting locally on our host, we need to use that private IP that gets assigned. And we can find that private IP out by running the Docker inspect command. So we say Docker inspect my container name, and that's going to pump out a load of information, but we're looking for just a bit at the end of this JSON format file. That's the IP address, and there it is. We can use that and drop that into Management Studio and connect to our container. If we're connecting remotely, we can use the container host IP, a port number that we identified upon container runtime, so that 15789 there. Cool. So let's go through pulling an image down and building our first container. So I'm in my project, so I'm going to say Docker search Microsoft /MS SQL. Cool. What we're going to look for is, because I'm working with this Linux container, I'm going to go for this book here, which is the SQL Server 2018 edition on Linux. So I'm going to say Docker pull Microsoft /MS, if I could type, server Linux, and hit execute. Now I'm executing here because I already had that image downloaded into my repository purely just in case anything went wrong. But it is a very, very fast process. So I can verify that that is in my repository by running the Docker Images command. And there it is, Microsoft SQL Server Linux. Okay, so I'm now good to go and building my first container. So I'm going to say Docker, run me a container in detached mode, mapping port 15789 on my host to port 1433 within my container. I'm going to specify my environment variables and accept the end user license agreement. And then I'm going to specify my SA password. Now, the reason I'm setting these in capitals is because if you're working with Linux containers, you have to specify the environment variable SA password, just this bit, in capital letters. Otherwise, it'll be ignored and the SA password won't be set and you won't be able to connect your container. So when I'm working with containers, I've just made it a good habit to always put those in capital letters, whether I'm working with Windows or Linux, just in case I forget. So there we are. Given my container a name, my first container, and then specifying the image I'm building my container from. Cool. Hit execute. Boom. Okay, that seemed kind of fast. So is my container up and running? All looks well. Okay. Now, if I went to a server container and I was on my host, I'd be running the Docker inspect my first container. And I'd be pumping in that IP. I can't use Zoom for no money for some. IP, dropping in that IP with my SA username and the password I specified. But one of the little quirks of working with Linux containers on your Windows 10 box is you can't use that IP address. You have to use localhost and the port number that we specified. So if I spin up Management Studio, connecting, I have localhost here, 570, put in my username and password, and hit execute. I have SQL Server up and running in, I think that was 2 seconds. It's pretty cool. Okay, so that's really good. We've pulled an image down from the hub, and we've built a container from it. But it's an empty instance of SQL. And I know there's PowerShell gurus out there be like, that's not a problem. What we can do is run a PowerShell script now that will restore all of your databases into your SQL instance within your container. And that's awesome, but it's kind of missing the point of containers. What we can do with containers is take that image and customize it so that when we spin our containers up, our dev databases are there and ready to go. We do that via a Dockerfile. And a Dockerfile is a file on the Docker host that contains a bunch of commands that will create us a custom image when executed. Let's have a look at the example one here, and I'll go through each of the commands. So we start off with from Microsoft-MS SQL Server-Windows. So we're going to build our custom image based off the vanilla image that we just pulled down from the hub. Then we're running a PowerShell command to make a directory called C-SQL Server within our container. And then we're going to copy a couple of database files into that containers in the directory that we just created. Notice that the database files here don't have a file path. So if you do this, they have to live in the same location as your Docker file. Then, because I'm forgetful, I'm going to set an SA password and accept the end user license agreement so I don't have to specify them when I run my Docker command. And then last but not least, the most important command, the environment attached DBs. And this is where we attach our database into our SQL instance within our container. So we just specify the DB name and then the files. You can specify more than one database, and you can specify a database that has more than one data file. I've just kept it nice and tidy here because it fits nicely on the slide. So we've got our Docker file. We now need to build our custom image, and we do that via the Docker build command. We say Docker build an image -t, tag it within image name, my first image, and then there's a dot there. And what the dot does is say, look in the current location that my shell is in for a file named Dockerfile and run that. You don't have to use dot. You can specify a file path, but I've made it a good habit just to do it for this for no particular reason. We hit execute, and then you can see at each point the Docker engine stepping through each of our commands, building intermediate containers, and at the very end, saving our intermediate container and building our image. So once that's complete, we then need to verify that it's in our repository. So we simply run the Docker Images command again. Say Docker Images, and there is our custom image. A little bit bigger than the other one because I've copied a couple of database files in. So that's really cool. We now have a custom image in our local repository, and we can build containers from it. So we run the command again. So we're saying Docker, run me a container -d in detached mode -p 15777, different port number because you can only have one container listening on one port on a host. Oh, and by the way, there's no rhyme or reason for me using these port numbers. I am literally just picking ones in the 1500s just because I can. So we're mapping that port number to the 1433 within the container, giving it a name, and then running it from the image we've just created from the Docker file. Hit execute, wait for it to come back, and then we can connect to our container and verify that our database is there. So in the example here, I've used the container host IP and the port number that we specified because I'm connecting remotely. So let's run through that now. Okay, disconnect from here. Well, I'm going to use my Linux Docker file. It is slightly different, if you notice. The main difference, well, apart from like Linux and the file path, is this bit here. Linux containers do not have the ability to run the attach dbs command as an environment variable. So I have to get a little bit creative. What I'm doing here is health check of interval of 10 seconds and saying, hey, wait for the containers to come up for 10 seconds, make sure SQL Server is running, and then run a SQL command to create the database from 2 files that are within my container that I've copied in these commands further up in the Dockerfile. So cool, that's the Dockerfile. On my host here under D, Docker, so my data files, my data log file, sorry, with my Dockerfile, so I need to navigate to that. Can't remember. So I'm going to build my image now. Say Docker, build me an image, tag it with a name, my first image. Oh, and one little quirk, whether or not you're working with Windows or Linux containers, your image name has to be in lowercase. Your container names can be in any case you want, but for some reason, Linux names, image names, sorry, all in lowercase. And finally, I'm just going to say dot. Hit execute. And we're waiting for it to step through each of our commands. Boom, excellent. Okay, I have a warning here, and that warning is saying that I'm building a Docker image from Windows against a non-Windows Docker host. Now, it's just a warning about the permissions on the files that have been copied in, so it's nothing too much to worry about. What is kind of cool about this, though, is that that database A, MDF, and LDF files were actually created locally in a SQL instance running on Windows. So I'd be interested to see if I can build a container and attach them without them throwing up a load of errors. I'm just going to come back here. Let's verify that the image is there. Cool, there it is. And now let's run a container from it. Docker, run me a container in detach mode, map import 15777 to 1433, giving it a name, my custom container. Notice I'm not specifying that I have to accept the end user license agreement or an SA password. They're already baked into the image. And then just saying my first image. Hit execute. That's come back pretty quickly as well. So let's run Docker PS. And there is my new image with a status. The status up. Okay. So back to Management Studio. Come in here. Localhost. Remember, it's a little bit different from Windows. I have to use localhost and the port number I specified upon container runtime instead of the private IP address that's assigned. I think this is to do with the fact that it's running in a Linux VM on my Hyper-V manager. So type in the password. And let's see if our database is there. Haha. So that's pretty cool. We have, so the 3 paths we've done. Have installed the Docker engine on our server or our host. We found an image that we want from the Docker Hub and pulled that down into our local repository. We started building containers, but they were empty containers, and okay, it's fairly handy, but we could do more. So we built a custom image using a Dockerfile that had all our databases in it, ready to go as soon as we spun up a container. And this is probably the most powerful thing when it comes to working with SQL and containers, is that you can customize any image from the Docker Hub to your needs and spin up containers in a very short period of time that have your dev databases ready to go. Cool. Okay. So we've built our host, we've built our custom image, and we are spinning up containers and testing against them, blowing them away and spinning more up. And we're happy as Larry. It's working really well. But there's a dev department down the corridor from us in our office that they've built their own container host, and they want to get on this action as well. Now, we want them to test against the same configured instance of SQL Server as we are and the same databases that we are. So we need to share our custom image with them. And because they're local, we can use the save to do so. And what this does is exports an image to our local file system that we can then push over to their container host, and they can load it in. So we just say docker save -o output my exported image.tar, giving it a file name, and then my first image. One thing I will say about the .tar is I did all these demos originally on Windows, and I tried .zip, and every time I tried .zip, I managed to corrupt the exported file. But .tar worked an absolute treat. So I just kept using .tar. So we hit execute on that. There's no progress with this. You just kind of have to wait for the command, the shell to come back to you. And then you can see the image on your file system. So we've got our custom image saved to our file system, and then we can push it over to the other development team's container host. And they can load that into their local repository using the Docker load command. We say docker load -i input myexportimage.tar. And what that does is takes our custom image that we've exported and loads it into their local repository. And that's great. Once they've imported their image, they can start building containers from it, and we can guarantee that they are testing against exactly the same databases that we are, because they're using the same image. So both of our development teams in our office are testing and using containers. We can guarantee that it's the same image, and we're all great. But we have another image. We have another development team, and they're a remote team, and they work somewhere else in the world. And they want to get on this. They've built a host. So how do we give them our image? Now, I know, okay, there's FTP sites, but we're working with Docker. So we have access to the hub. And now we've already interacted with this. We've pulled images down. But not only can we pull images down, we can push images up. So jump onto the site, log in, choose a username and password, and then we can build a repository online to store our images. So the one I've got here, I've just given it a name of test SQL repository for my test SQL images, and then I have options here of public or private. You need to be a little bit careful with this. If you choose private, only you can see that repository. If you choose public, anyone, and they mean anyone doing a Docker search, can see your uploaded images. So just be careful and be aware that that can happen. There is another option. If you go for a paid account, I think you get options to specify users that you can share images with, but I'm cheap, went for the free account, and these are the only two options I've got. But I've created my repository. First thing I do is tag my image with my repository name. So I say docker tag my first image, and then my username / repository name, and I always give it another tag, say like v1, v2 latest, so I can identify where in the development process I am. Hit execute on that, and it's pretty much instant. And what it looks like, it's copied the image name, but if you have a look here, actually the same image, just duplicated within your repository. But we tag our, the next thing to do is now log into the Docker Hub on the command line. So we say docker login, drop in our username and password, hit execute, hopefully everything's gone right, login succeeded, and we can now push our image to the hub. So we say docker push the new tag name, execute. Depending on how the image is, this can take some time, so you might want to go away, make a cup of tea. But once it's complete, we can verify that's in the hub by jumping back on the website, refreshing our website, and we should see our image there. So that we can now give our remote team the ability to pull that image down to their local repository, and they can start building images from it. Let's go through that now. So let's just close it out. Clear all this. Okay, so I've got my images there. And I've got my repository here. I've got a list for you. Just verify there's nothing in it. Cool, nothing there. Okay. Now, Docker tag my first image with DBA from the cold test SQL repository. I'm going to call that Linux test. Instant. Check the repository. Looks like there's two images there, but if you take a look again, both have the same image ID. It's really the same image, just with a different name. Cool. So, tag, next thing to do, log into the hub. So docker login, DBA from the cold, my password. Hey, first time. Haha. Okay. So I can now push my image up. So I'm going to say docker push DBA from the cold test SQL repository, Linux test, and hit execute. Now we're getting things that already exists there because our image is based off the Microsoft image, so it doesn't need to put the entire thing up. When someone pulls this image down, Docker's clever enough to know, oh, I need to get stuff from that image and that custom image. So we just had to push up now. It shouldn't take too much longer. Any second. Excellent, and that's completed. Okay, so let's have a look online to see if that image is there. There we go. Linux test, 482 meg. And we have successfully tagged our image, logged into the Docker Hub, and pushed that up to the cloud so that our development teams can use that image and pull it down and build their own containers from it. And that, for me, is the real power behind using containers in this technology. Custom images and the ability to share them easily. Okay, are there any questions at the moment? I'm going to go with no. Okay. So that's pretty much all I wanted to show you with containers and the commands available. What I'd like to do now is just go into how I've implemented containers. So a bit of background. My QA and dev departments all test our applications on QA on VMs that have our full production stack. And that means each VM has to have a local instance of SQL Server. And they're constantly blowing away these VMs, rebuilding them, and reinstalling SQL Server each time. The method of installing SQL Server is via Chocolatey. If you don't know what Chocolatey is, it's an application package manager for Windows, something like apt-get for Linux. And then once they've installed SQL Server via Chocolatey, they then restore a load of databases that we keep in TFS, that are very small and just have reference data needed by the application via a series of PowerShell commands. We call these databases baselines. And the problem with this was it wasn't the most reliable process in the world. It was prone to failure, and when it did fail, the dev is left trawling after Chocolatey error logs or SQL Server error logs, working out what went wrong, uninstalling any bits of SQL that got half installed, and then starting the process all over again. It also wasn't the quickest process in the world. The hosts that the VMs were running on weren't exactly the highest spec. We're talking 52K disks, CPUs, I think 10 years old, maybe older. So I saw anywhere between 20 to 40 minutes just to install SQL Server, and then the restores of the database took a ridiculous amount of time as well. So there really had to be a better way. And that way, of course, containers. We can implement containers running SQL Server for all new QA VMs. So what we're talking about is removing the local instance of SQL Server from all the VMs and pointing those VMs at a container host, and each VM having their own container running SQL Server. The SQL containers will be built from a custom image that contain all of our development databases. So there's no longer any need to install SQL Server. There's no longer any need to restore any databases. And what's even better, because SQL's not on 30 to 40 VMs, we're freeing resources not only on the host, but the VMs themselves. So they're going to be a little bit snappier and nicer to work with. However, I instantly ran into a problem when I was looking at this technology. I said right at the start of this that this stuff is only supported on Windows Server 2016, running SQL Server 2016 or SQL Server 2017. We're running neither. We are running SQL Server 2012 SP3 on Windows Server 2012 R2. Bit of a blocker. So I had to go out to Google, start searching, and I eventually found a solution in a company called Windocs. And what Windocs have done is taken the open source software that Docker have made available to the market, the community even, and build a custom port of it, which allows for earlier versions of SQL Server to run in earlier versions of Windows Server. 2008 and upwards, both cases, I think. Absolutely brilliant. That's exactly what we needed. And what's even better, and the reason I mention this, is that they do a free community edition as well. And that's what I went for when I did my initial testing. So I went to my sysadmins and said, hey, do you have a spare server that lying around that I can use? And as luck would have it, they had this banged up, beat up old box that they let me have. So I wiped it, reinstalled Windows Server 2012 R2, and followed the Windows installation instructions. And here's what we ended up with. Now, this looks very, very similar to a vanilla Docker install. We have our host and all our VMs connecting to containers on custom ports. The difference is this SQL Server instance here. This is a default instance of SQL Server and it is not running. Now, the reason for that SQL Server instance is that when the Docker Windocs or the Docker daemon spins up, it looks for that default instance binaries and builds you an initial image that you can build containers from. Remember, there's no 2008, 2012 instance up on the Docker Hub that you can pull down. So that's how you get your initial image. And that's really cool. That instance isn't running, by the way. It's always off. Another really cool thing about it is the Windocs, again, does things slightly differently as it uses that SQL instance's binaries to build containers, build SQL within the containers when they get up and running. So that means any changes to that SQL Server instance's binaries will be replicated in all new containers. So if we patch that instance of SQL Server, that one instance of SQL Server, that will be replicated in all new containers. Well, that's really cool, because if you think about it, I'm running SQL Server 2012 SP3, and I know before I started this project, I would have had to patch 30 to 40 QA VMs, or have got them to patch it for me. But now all I do is patch that one instance, bring it up to SQL Server 2012 SP4 when it's released, get them all to blow away their containers and rebuild new ones, and I got 30 or 40 instances of SQL Server 2012 SP4 that can do my testing for me before I deploy it to my staging environment and then my production environment. An absolutely unexpected benefit. Absolutely love it. Okay. So did apart from the cool patching stuff. New to VMs deployed in a fraction of the previous time. Okay, so we no longer need to install SQL Server and we no longer need to run any PowerShell scripts to restore the databases. We timed this process, and the longest it took us to get a instance of SQL Server up and running in a container with about, I think it's off the top of my head, 30 development databases ready to go, properly configured all our logins, was 2 minutes. 2 minutes for a full-blown instance of SQL Server, well, database engine up and running, but good enough for our QA guys to test against. 2 minutes as opposed to 30 minutes to 40 to install SQL and then the rest of the restores. Okay, they're not the biggest databases in the world, but they are exactly the same size databases that we used in the previous process. So whichever way you look at it, that is a huge saving. The next one, the base image can be used to keep containers at production SQL instance patch level. Yep. So when we release to production, we update our custom image. So when the guys spin up a container, they know all those databases are at our current production level. And the last point there, more VMs can be provisioned on the host due to each VM requiring less resources. Yeah, hasn't really happened. The idea was we'd limit the resources to each VM so we could build more on the host. But the guys found that their existing VMs were so much more snappier and nicer to work with that they wouldn't let me do anything like that. So that one hasn't happened, but I don't really blame them for that. Of course, wasn't always smooth sailing. We did have some issues. Chief, which top one there, nearly scuppered us. Our apps use DNS entries to reference SQL Server in production, which is fine. You know, we have CNAME aliases everywhere. And that's replicated on the old style VMs with a local instance of SQL Server by hostname entry files that overwrite, say, like production DB is now 127.0.0.1. And that's absolutely fine. But what we've done here is we've taken away that local instance of SQL Server. And not only is it now a remote instance of SQL Server running on a different host, but it's also listening on a non-default port. And it's that non-default port that nearly scuppered us, because you can't reference a port number in a DNS entry or a hostname file. So what did we do? Well, change the application string, right? You just keep the DNS entry, just drop the port number into it, and you're good to go. Unfortunately not. One of the prerequisites of this project was we couldn't make any changes to the application, which is fair enough if you think about it. You don't change an app that you're going to deploy to production purely because you've changed your development environment. So what did we do? Well, we used SQL Server client aliases to replicate our DNS entries on each of the QAVMs. And what's really cool is that SQL Server client aliases allow you to specify a port number. So what happens, the guys actually run a PowerShell script on their QAVM, or they can use Octopus Deploy now as well, to spin up a container, grab the port that it's listening on, and then create all the client aliases that their apps will need locally on their QAVM. It's absolutely brilliant. This apps spin up. They think they're talking to a local instance of SQL, and they're actually talking to SQL in a container on a remote host. Absolutely brilliant stuff. Really pleased with that solution. I really wish I came up with it, but unfortunately, it was the other DBA who works for me, so he has to take the credit for that one. The next point there, update to existing test applications. We have a bunch of custom in-house applications that we can change that buried deep down in the code as a connection string with server equals dot or localhost, so we could actually go in and just change that. Trial and error to integrate with Octopus Deploy. We deploy all our applications via Octopus, and they all deploy slightly differently. So it's just a matter of changing either the configuration of the container, things like logins, or the Octopus deployment process, not the application, just so that everything worked as expected. And the final point there, new ways of thinking. So people are used to SQL being this big behemoth that just sits there. Okay, you might drop a database and restore a database once it's installed, but you don't really do anything with SQL itself. Containers change that a little bit by saying there's no point in dropping and restoring a database. It's actually quicker to blow away the container and build a new one. Let's just get people's heads around to thinking that way instead of thinking of SQL as this standard object that'll always be there. Thinking of SQL servers now as a throwaway object for development environments. Okay, final few slides, just a couple of things. So I mentioned right at the start that there aren't any images, official images, Microsoft SQL Server that are for earlier versions of 2016. So what I've done is I've built a custom images up on the Docker Hub that you can download for SQL Server 2012 SP3 Development Edition or SQL Server 2014 SP2 Development Edition. So those are freely available. If you don't want to use Windows and you want to use Windows Server 2016, you're more than happy to pull those down and play around with them. And the link there is to my GitHub account, and that actually has all the code that I've used today and the Docker files that I've used to build those custom images as well. So you're more than welcome to have a look at that as well. Portainer. So everything I've done is via the command line. One of the questions I usually get is, I don't mind working with the command line, but what I really want is a GUI that I can use to manage my container host. Is there one out there that's nice and easy to set up? Well, there is. It's called Portainer. It's open source, and it is available as a Docker image, or you can download it freely manually from the site. It is a little bit tricky to set up with Windows hosts, but I've actually written an article on my blog that tells you step-by-step instructions on how to get up and running with this, and it is pretty cool. It gives you pretty much everything that we've done in the demos today. You can do through this through this portal, so it's pretty cool. Summary of my container series. So I've written a whole bunch of stuff, and there's a link there that has just one post with all the links to all the different articles that I've written. The case study that I talked about with how I set containers up at my work has been published on SQL Server Central. I think Tom said right at the start that he listened to the podcast with the SQL Data Partners. There's a link to that there. And the final link there is how to set this up on Windows Server Core, which I kind of think this stuff should be run on Windows Server Core because, well, everything you do with the engine is interacted via the command line. So why waste resources on a GUI? You want to run containers on this. You want to give every single spare bit of resources to your containers. So don't bother with the GUI. Run it on Windows Server Core, and you absolutely can. There's just a couple of initial steps to go. So I've had that article published on SQL Shack, and you are more than welcome to check that out. Cool. Are there any questions?
Well, we don't have any questions right at this point from any of the attendees, but we'll kind of wait a moment and let them put some in there. I've got a couple just to kind of try to understand and wrap my head around this myself, because like I was telling you, we've been investigating possibly doing this. So the one would be, does the container have to talk back to the host at all, or is it really just you can throw it out there and basically there does not have to be connectivity back to the host?
As in, well, I think that if you want to connect to the SQL instance within the container, there does have to be a network setup there, yeah.
Okay, so if you had a remote, because we have remote developers and stuff, so if
Yeah.
you turned around and actually say they lost connectivity at their house or whatever, or I was traveling on a plane from point A to point B,
Hmm.
you're basically saying that I would not be able to use a container at that point?
Oh, so basically, if you're working on, say, a laptop and your application is talking to the container host, or if you're running locally.
Well, I would be running locally. I'm thinking that I would have Docker, say, installed on my laptop. I'd bring
Yep.
down the image, the Docker, the Docker container down onto my laptop, and I'm, on a plane 30,000 feet in the air. Is there any connectivity back to the host at that point, or can I use it?
You can
Uh,
use it. It's because it's all running locally, so you'll be able to connect in. So you don't need if you're working on where if you're working where Docker is running, you shouldn't have any issues connecting to containers. It's obviously only if you're remoting into your container host would network connectivity come into problems.
Okay, all right. So you can do that. Now, I'd heard on your podcast or read somewhere from you, if you do you have like a ratio that you have seen the size of, say, a SQL Server VM image versus the size of Docker once it gets down to the container? What
Okay,
is it, about three quarters, or do you know?
not off the top of my head, because it's kind of how long is a piece of string with that one? I mean, so I see. I mean, if you strip everything out of a VM and just have a bog standard VM running SQL Server, how does it compare to the Docker just running as it is? I, I don't know actually off the top of my head. I'll make a note of that and see if I can do a comparison for you.
Okay, because yeah, I was kind of thinking, like if I have say I have a product that has four databases and all those databases equal up to, let's say, 30 gig
Hmm.
on a VM, if it was a VM and running SQL Server, then if I actually brought that to a container, is it going to now be, let's say, 20 gig, or does it get into the megabytes, or anything like that? And I think I've seen things that they're still a fairly good size. And again, I'm thinking from a remote person that might have to copy this Docker container down with,
Hmm.
say, a database that's been obfuscated, because
Okay.
say it's got my production data, the size of my production database, but I've obfuscated the data so that he can use it.
Okay. So I think the main thing with Docker is that if you're building from an image, you'll get compression from on your host from that. So you're building um, multiple containers from the same image, and because they all use the same binaries, you'll save space the more you use them. Whereas with VMs, I think you get the whole phone OS going into each one. I'm not too sure how the back end would work there. But actually that's a very good point. I'd like to go into that a little bit more and actually do some sizing and get some numbers for that. So I'll make a note of that and I'll research into that more for you.
Okay, yeah, it's just a matter of, kind of you know, am I looking at three quarters? So if I'm having to transfer 30 gigs worth of databases over backups over the internet, or
Yeah.
the connectivity, now am I going to get down to 20 gigs over the internet, or 10 or 15 or whatever? So
Would it be worth putting them into a Docker image and putting them up in the hub, seeing what the ratio of saving it is. That's
Yeah.
okay.
Something to think about. All right, I've got a couple questions. Larry puts his questions out there. He goes, if you build or access a Windows 2016 core image to a host a couple of SQL Server containers and have a Windows 10 workstation, do you need a license for that Windows 2016?
If you do need a license for Windows Server 16, but you don't need a license for Docker Enterprise Edition because it comes with your Windows Server 2016 license. Or if you are working with Windows 10, you'll pull down the Community Edition to your local VM, and that's free as well.
Okay. Next question. Although this seems to be best suited for test or development setups, how would you recommend backing up or exporting any data on the instances after you've done with them on the container?
So we're asking how to persist data in containers. Is pretty much.
Yeah, that's what it looks like, yeah.
Cool. I was hoping someone would ask that. So is my VM working here? Actually, going to jump onto a, can you see that? This is a little bit slow.
Yeah.
Cool. So what I have here is my Windows 16 box. And what I've got is a data drive with two database files, exactly the same data files as we used before. Now, instead of copying these into a container, what I'm going to do is mount that directory into the container. I do that. It's very simple. Wrong one. So pretty similar here, command, just a Docker run command. What I'm doing is using a vSwitch here just to map that. I'm not copying anything, I'm just mapping that volume into my container. So let that spin up. Come on, Docker. Which the idea is here is once I connect to this and say Docker inspect, is that test container 1? I can grab my IP address. Connect to it. Oh, I can't type. Oh, Andrew, come on now. And I have access to that database. If I attach it, so what I would be doing if I was actually doing this for developers would be scripting this all out. But just as a demo, I'm going to attach that database in. This database is empty in it, he says. So there's absolutely nothing there. So I'm just going to say something along the lines of run a query and just say create table, test table. I'm using my database. So ID, and that's int. Let's insert into test table. ID values. Go. Andrew. 10. Excellent. So we have it. We've mounted a directory, attached our database, changed it a little bit, but now I don't want to use that container anymore. I'm going to blow it away. So what I'm going to do is stop test container 1. Disconnect in my studio. And now I'm going to build another container, bring the same volume in. Actually, what I'll do is, do I still have the container running? I'll actually blow that container away completely. So Docker RM test container 1. Bye-bye. And let's spin up another one. So I'm going to call that test container 2. Change the port just because it's just a different container. Spin that up. I really hope this works. Cool, that container is up and running. Grab the IP address because I'm connecting locally on my host. There it is. Cool. Need to attach that database again. So again, I'd have scripted this out in a PowerShell script to spin the container up and then connect and attach the database. And this is freezing up on me. Come on. There we go. Right. Oh joy. There we go. So I have that directory there again, database A. Okay. Okay. That table's there. It is with our data. So by mounting that directory, changing our database, and then remember, I didn't disconnect that database from the container. I just blew that container away. And then I spun up a new container, mapped it back to that directory, and attached that database, and the changes were persisted. So that's one way of within containers, if you don't want to just use them as throwaway objects and blow everything away. And there's a couple of other options you've got there where you can create volumes and things like that. I've actually written a persisting data series in containers specifically for SQL Server, 3-part series, which is on my blog if you want to check that out.
And I'm assuming when you're doing that persisting data, it has to be at least the SQL Server version that you had at the time of the object or greater, right?
Yes. Yeah. So it will. It's basically an attach process. So if you create it in 2016 and you attach it to 2017, you'll see that it'll upgrade it for you. But yeah, the same rules apply. You can't go back a version.
Right. That's where I was getting to. Is you can't go back. You still have SQL Server rules there. So
yeah, definitely.
All right. Okay. Well, I don't have any further questions there. For everybody that's on the line, we will be posting this up on the virtualization SQLpath.org website with the link to YouTube with the presentation. And this is very interesting. I know I'm researching it, and I appreciate your time, Andrew, and have a great.
That's absolutely no problem at all, Tom. I'm very active on the SQL community Slack. There's a containers channel there. So if anyone has any further questions, feel free to give me a ping.
All right. Sounds good, Andrew. And we look forward to talking to you more.
Cheers. Bye now.
Cheers. Bye.